Hello and welcome back to the Master of Your Academic Skill channel. This is the second part of mathematical expression typesetting in Latex. And if you like this video, keep watching this video up to the end. Be sure to subscribe my channel and click on the bell ring to get notified when my new videos are uploaded. There are some symbols in Latex for mathematical expressions, and I'd like to show you them. The first one, let me give some dollars. Yes, the first one is partial symbol. Partial is used for partial derivative. Let me compile it. Yes, this is partial. Another one is F. Yes, compile. Another one is H bar. H bar. Another one is different. Yes, H bar. Another one is this is for imaginary part or different form of math. Here's name I math. Yeah, this is I math. We have another one, J math. Okay, J math. See, we have. I should not add a blank line in the mathematic expressions. So if I compile it, I have J math. Another one I have L. Yes, L is another form of L. You see, this is used in mathematics. Another form for real number, just simply RE. Yes, for real number, for real part or real number. Another one is imaginary. IM for stands for imaginary. IM. Yes. Another one is WP. WP. You see, this is WP. Nabla is another symbol. Nabla. This is the inverse form of delta. Yes, it is not. It is named Nabla. We need box. Box for a little square. You see how the little square is box. Infinity for infinity. Yes, infinity or infinity. We have it, and some Hebrew letters such as Aleph. 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 This is Aleph. Bet or Beth, and Gmail. Yes, these are some other symbols in typesetting or mathematical expressions using. I think this is enough for other symbols, but we have lots of logical or row symbols that I will talk about them later. Now let's focus on trigonometric functions. As usual, for each trigonometric functions, you have to put a backslash behind of its name. For example, I have sine. Let me compile it. Yes, I have sine. I have cosine. Or I have tangent. Let me compile it. Yes, I have cotangent. Yes. Okay, I have the inverse of them. For example, arc of sine. Let me copy it and soon arc and arc. If I compile it, you see these are arc sine, arc cosine, and arc tangent. Another one is hyperbolic function. For example, hyperbolic sine or sine of hyperbolic. Yes, I have the same. I can change it to cosine of hyperbolic form or tangent of hyperbolic form. Let me compile them. Oh, let me clean these parts. Yes, clean these parts. And I have the sine of hyperbolic and cosine of hyperbolic and tangent of hyperbolic form, and secant and cosecant, they are cosecant, they are all trigonometric functions that we need in latex. Oh, I think yes, the cotangent is forgotten. Yes, cotangent is, yes, the cotangent. If you compile it, you have the cotangent here. I think that's enough for trigonometric functions that we need in latex. Another functions in latex that we need to typeset them are exponentials. Yes, exponential are simply typeset, but exp. Yes, exponential of, for example, minus x. Let me compile it. Yes, I have exponential of minus x, and I can typeset a modular operator, for example, b mod. Yes, b mod b. It gives me the modular, yes, the mathematical form for a mod b. And another one is p mod. Let me show you. For example, x is equivalent, for equivalent we have the command equivalent to a by p mod of b. P mod, it has another b, it has an argument b. Let me compile it. Yes, x is equivalent of a by mod of b. This is for modular operator. Now let me show you how to typeset a limit of a function in a latex. Okay, if you use lim command, you have the limit symbol here. Okay, but I needed, for example, I need to typeset limit of an exponential when the argument tends to infinity. Okay, if I put the exponent minus x, okay, I have this one, but I like to typeset when the x, the argument tends to the infinity. To do this, I have to put it into limits. Yes, limits. See, I have limits here. Let me remove the limits. Limits x to infinity. Yes, infinity. And the argument, the function that I like to take a limit of them and equal to 0. Yes, it's a very simple example. Let me compile the file. Yes, this is the mathematical expression that we have seen in lots of mathematical book. I have a limit of an exponential of minus x when x tends to 0, that is 0. Yes, now I have the expression as a superscript of these expressions. Sometimes you may use a bar in your mathematical expressions. For example, you have a mathematical expressions as f of n of x to power 2 plus 2x bar. Let me show you what it is. Okay, I have a bar here, and I like to explain that what was 2, and for example a was 2. Okay, a equal 2. If I compile this one and this, what I wanted, because I like to typeset a equals 2 as a superscript of a bar. So I have to put it a equal this expression, I mean a equals to 2 as a superscript for bar. And now let me compile it.